Today's session is about the new chapter called statistics. What is statistics? Statistics is collection of data or observing the data or analyzing the data. What is data? So let's come across these command terms which are strictly used in mathematical sense in the topic of statistics. Before that, we understand what exactly is the use of statistics or what is statistics. Introduction. So statistics in general sense is about, say for example, we take one real life situation where the teacher makes the list of all the marks of the students name wise. For example, I have the name, the roll number, marks which are calculated out of 20 and then percentage of those marks. So imagine a teacher is trying to make the different statistics, the data of different collection of marks and their students' names and roll numbers. Say a student with name A and roll number 1 has got the marks 17 out of 20, or he got 10 on 20 and his percentage is 50% of 100. And say student B, whose roll number is 7, has got 15 marks out of 20 and his percentage is 75%. So this collection of the names, collection of their respective roll numbers and their marks obtained for 20 marks in the math subject, their math marks obtained and the percentage of those marks is what the list, what teacher usually does before they prepare the progress card. So this can be one of the purest and the best example to understand statistics. So the teacher is trying to collect the data of all the marks and trying to analyze the marks obtained through the percentage, and then the student would realize, and then the teacher would realize where the student is standing. So this gives me a clear picture. Say I take student C with roll number 5 and they got cent percent, which is 100%. And finally, I take student D, roll number 3, got 5 marks. So this gives me a clear picture that the student who got 25% is below average or at low performance, and he is excellent, good, and mediocre. So here we try to give the different names as here, poor or very poor. So the teacher gets an idea with this statistical data that the marks which the students have obtained can be rectified and then proper care taken for student D, and improvisation principles applied for student A. So therefore, my statistical data helps me in analyzing the data and making positive outcomes. The teacher here has analyzed the data of marks into the percentage and made some precautionary measures. Student D and student A are taken proper care of. So in mathematics, we have many real life situations which are converted to data, which are converted into analyzing the data and then understanding the real life situation through the data, which is called statistics. So let's see the definition in brief on what is statistics. In more simple sense, let's try to define what is statistics.
Statistics
is the collection of information which is investigated for its statistics is the collection of information which is investigated for its effect on the situation. For example, the population of the country for different years is the information which gives us on the effect which gives for situation. For example, population and year. If I take the year and the population, what happens? Let's see. Say I start from 1980, 1985, 1990, 95, 2000, and this, so on and so forth. And let me say the population here is 60 million, 70 million, 75 million, 80, 85, 93, 97, 100. So this is all about the population of the country every 5 years. So the year which is calculated with population every 5 years accounted with gives me the effect, like it gives me the collection of information which is being investigated. Because the population is increasing every 5 years, as seen from this table, I take precautionary measures because 100 million seems to be a very big population. Therefore, statistics, which is the collection of information, is investigated for its effect on the situation. And then precautionary measures are taken. Now clearly this table gives me that this has serious effect on the situation, because if the population of the country increases very much, there will be scarcity problem, food problem, house problem, and many other problems which arise. Therefore, through statistics, I conclude that I need to take precautionary measures from the year 2015, which is the population 100 million on the whole. Statistics helps me in controlling the situations by studying, analyzing, observing the given information, the information which is called data. Next, let's discuss the next mathematical sense of data. What is data? In statistics, data is of two types. One is numerical data and the other is non-numerical data. But general sense, data is nothing but collection of information. In mathematics, data is defined as collection of information. And the collection of information can be of two types. One is numerical and the other is non-numerical. For example, collection of students' marks is numerical data because it involves the numerics or the numbers. And here, collection of students' names cannot be numerical data because it does not involve numerics or numbers. It involves the names of the students. So clearly through this example 1 and example 2, I understand the difference between the numerical and non-numerical data. Collection of students' marks, which involves the marks in numbers is numerical data, collection of students' names, which involves only the names of the students, is non-numerical data. In general, data is collection of information. It's also very important to note the plural form of data is datum. I cannot say there are 4 data collected. I can say there are 4 datum collected. There's 1 data, 4 datum is how I understand. The plural form of data is read as datum. Now that we have discussed about data and its definition, let's see the different types of data which are existent in mathematics. This session is about types of data. There are 2 types of data which we identify in the branch of mathematics. One is primary data, the other is secondary data. So what is primary data and secondary data? It's very easy to understand that. If I directly involve in collecting the data, then that's called primary data. If I pick the data from some other external resources like the internet or the web search or various other media or from published books, we say that data is secondary because you're not directly involved. So here the most simple definition of primary data is the data which is collected practically by involving oneself in the collection process is called primary data. The data which is collected practically by involving oneself in the collection process is called primary data. And here the secondary data is the data which is collected from external resources like library, internet, media, etc. Such data is secondary because you're not directly involved, but you're trying to depend on a book or a computer or any other electronic media, etc. to get the data. Depending on something, we get secondary data. Not depending on something, directly involving oneself, I get the primary data. Primary data and secondary data are the types of data in the branch of statistics. Now that we have discussed certain command terms in statistics, let's continue further to take an example problem and understand few key mathematical concepts used in statistics. First thing is about the raw data. So raw data is generally assumed to be that data which is directly taken as the values listed out. For example, marks obtained by 10 students in class, if it is listed out I just take the raw data because it does not specifically include. Obtained by 10 students in class is 50, 49, 70, 35, 48, 92, 83, 74, 12, 46. So here I have the marks of 10 different students taken out here, but it doesn't give me complete information that that particular student got this marks. It just gives me a rough data about marks obtained by 10 students in the class, but not specifically listed out with the names and the students' marks differentiated. So such a kind of a data which does not specifically give the specific definition is called raw data. So this is a raw data is how we understand in the branch of statistics. The data which does not have specific representation. For example, 10 students in class with the marks as listed out here is an example of a raw data. Now let's discuss about range. What is a range in statistics? This session is about range. Say for example, I have the marks of 10 students in the class which I have taken Now clearly I have the marks of 10 students in the class with all the marks listed here, which is the raw data. Let's understand what is the range. So in this case, a range is understood as the maximum value minus minimum value is how we understand the range of the data. So the formula for range is max value minus min value. In this case, therefore, the range would be the highest value, which is 100, and the lowest value, which is identified to be 48. Therefore, my range is 52. So in this case, for the given problem with students marks listed out here, the 10 students marks listed out here, the range is 52. Range is highest value minus lowest value. Now comes the concept of frequency. What is the frequency for the data? Let's see the frequency in this session. So in statistics, frequency is said to be the most occurring value of that given problem. For example, if I say the marks are 20, 21, 25, 21, 39, and 21, and 25, then let's see what is the frequency of each of them. For example, if these are assumed to be marks, and let's make a frequency column for that. Now here the marks are 20, 21, 25, 21, 39, 25. Now this being repeated, I don't take again the repeated values, and hence I get a table which has these values. Now let's see the frequency of each of the values in understanding what exactly is frequency in statistics. For example, I take the marks 20. Now the number of times the marks 20 repeat is called frequency. Here I see that 20 repeats only once throughout the given data, and therefore the frequency of 20 is 1. Similarly, 21 repeats once, twice, and thrice. That means the mark 21 repeats 3 times, and hence the frequency of 21 is 3. Is how I understand this. Next comes 25. The frequency of 25 is 2 because it repeats twice. And similarly, 39 repeats only once. It doesn't repeat, so the frequency is 1. So each value is defined with their respective frequency depending on the number of times they occur in the data. 20 occurs once, 21 occurs 3 times, 25 occurs 2 times, 39 occurs once. Is how we understand the frequency for the given data, is the number of times it repeats in the given data. This session is about construction of a frequency table. Now that we have defined what a frequency is, now comes the question on how to construct a frequency table. Constructing a frequency table. How do we construct a frequency table? Let's take some data to understand how a frequency table can be constructed for that given data. For example, I have the data 20, 21, 25, 23, 29, 30, 35, 37, 33, 24, then 40. Say for example, I have the set of data which is given by this, and then we take the data according to this given values. Now a frequency table is constructed with the marks or whatever values given here is defined as class interval. We take class interval and then we take the frequency. We have discussed recently that frequency is the number of times the data occurs, and hence if we take the class interval, we first pick the lowest value and then the highest value. So between 20 and 40, we try to classify as 20 to 25. 25 to 29, 30 to 34, 34 to 39, and 40 to 45. That's how we understand the classification out here. So here, let's imagine the values which are between 20 and 24 are 20, 21, 1, 2, 3, 4. That's it. So my frequency is 4. That means there are 4 numbers which lie between 20 and 24. Next comes 25 to 29. 1, 2, 3. So my frequency is 3. That's how we get it. Now between 30 and 34, 30, 2, 3, there are 3 values which lie between 30 and 34. 34 to 39, 35, and 37. Between 40 and 45, I have only one value which lies here. This is how a frequency table is constructed. Frequency table constructed for the given data using the class interval and the frequency. We break the class, the lowest being 20 and the highest being 40. We break the class into each of this interval being with 5 students, each with 5, and then we get the class frequency depending on the values as given in the given data. Construction of a frequency table. Now that we have discussed about how to construct a frequency table, there are two types of frequency tables which can be constructed. This example problem which I have taken has been divided into different groups, and hence we got a grouped frequency table. So this is called grouped frequency table because each of the marks are grouped and hence their frequencies are calculated. If you do not group the marks in order to obtain frequency, like in the previous example problem, if you directly take the marks listed and their frequency, such a table is called grouped frequency table. Frequency table is of two types. One is grouped frequency table where the data is grouped, and ungrouped frequency table where the data is not grouped. We directly take the data with their frequency. So here we make a very important note that when do we group the data or when do we not group the data is the biggest question. So here we have a very important note which makes us understand that the data is grouped if it is large in number. That means if you have a data which is 1000 or 400 or 300, then I cannot include the list of data with each value being calculated for frequency, but I can do the smart work of grouping. This being with very huge data, the data is grouped if it is large in number. If it is not in large number, we try to use the ungrouped frequency table. Grouped frequency table and ungrouped frequency table depends on the number of data given in the situation. Now that we have understood the listing of the data and how to construct a frequency table, now comes the concept of how this data can be represented graphically. This session is about graphical representation of data. It is very important to represent the data through graph because the whole concept of statistics is itself about analyzing the data in the real life situations. Therefore, the real life situation demands more of pictorial representation or graphical representation of the collected data. There are three types of graphical representations which we use most frequently in the branch of statistics. The three graphical representations which we are going to deal in the syllabus are bar graphs, histograms, and this. The three graphical representations of the data collected can be analyzed through the bar graph or through the histogram or through the frequency polygon. Let's see each of them classified individually.